Special properties of colloids. A colloid is a heterogeneous solution that contains particles of intermediate size of 1 to 100 nanometers dispersed in a continuous medium. Some examples of colloidal solutions are toothpaste, gum, blood, milk, and honey. Colloidal particles lie between two limits. They are bigger than simple ions, atoms, and molecules, yet not big enough to be seen under an ordinary microscope. Colloidal solutions consist of two phases called as dispersed phase and dispersion medium. Particles present in small amounts are called the dispersed phase. The particles present in excess, which behave like a solvent, are called the dispersing medium. Depending upon the nature of the dispersed phase and dispersion medium, different types of colloidal solutions are formed. Sol is a solid dispersed in a liquid like that of a starch solution. Emulsion is a liquid dispersed in another liquid, as in dilute milk. Gel occurs when a liquid is dispersed in a solid, for example, in jellies. Aerosol is a solid or liquid dispersed in a gas, such as in the case of fog, mist, or smoke. The particle sizes of a colloidal solution are such that they can pass through ordinary filter paper but not through a semi-permeable animal membrane. Observe what happens when a colloidal solution like milk is passed through a filter paper barrier and then through a semi-permeable membrane. Ordinarily, colloids cannot be seen by the naked eye, but can be viewed only under a powerful microscope. Brownian movement and Tyndall effect are two common properties of colloids. Brownian movement. The constant rapid zigzag motion in colloids is caused by the unequal bombardment of colloidal particles by the molecules of the dispersed medium. When more molecules strike one side of the particles rather than on the other, the direction of the motion changes. This is called the Brownian movement. Tyndall effect. When a strong beam of light is passed through a colloidal solution, the light is scattered by the colloidal particles. This scattering of light is called the Tyndall effect. The illuminated beam or cone formed by the scattering of light is called Tyndall beam or Tyndall cone. The path of the light becomes visible when viewed from a direction at right angles to that of the incident light.
Scattering of light. We've across some wonderful phenomena in our daily life, such as the blue color of the sky, color of water in deep sea, the reddening of the sun at sunrise and the sunset. Or, what is the reason behind these natural phenomena? For this, first we shall discuss about scattering of light. Scattering of light. When a beam of light falls on an atom, it causes the electron in the atom to vibrate. The vibrating electrons, in turn, re-emit light in all directions. This process is called scattering. Earth's atmosphere contains air molecules and other tiny particles. When light from the sun passes through the atmosphere, it gets scattered by the large number of particles in the atmosphere. According to Rayleigh law, the intensity of scattered light varies inversely as the fourth power of the wavelength of height, 1 by h power 4. Tyndall effect. John Tyndall was the first one to explain about the color of the sky in the year 1859. He stated that the color blue scattered more than that of red due to the shorter wavelength in a case where the light has to pass through a clear fluid that contains suspended small particles. Our planet Earth consists of various mixtures of particles like smoke, molecules of air, dust particles, and water droplets. These diffused particles reflect the light before it reaches the Earth. The scattering of light by the colloidal particles is known as the Tyndall effect. The size of the particles determines the color of the scattered light. This statement can be proved with the help of a simple experiment. Allow a beam of light to pass through a tank of water with a slight mixture of soap or milk in it. If you wash the beam from a side, you can notice that the beam scatters blue light. But when you thoroughly observe the beam from the end, then you will find that the beam is reddened after it has passed through the tank. Why is the color of the clear sky blue? Since the wavelength of blue color is smaller than the wavelength of red color, lambda b less than lambda r. Scattering of blue light by particles in Earth's atmosphere is very large. For this reason, we see a blue sky. Although violet light is scattered more than blue light, our eyes are not very sensitive to violet light. Color of the sun at sunrise and sunset. At the time of sunset or sunrise, the sun is near the horizon as shown in the diagram. The rays from the sun must travel more kilometers through the atmosphere than at noon. Therefore, more blue is scattered from the sunlight. The removal of blue leaves the transmitted light more reddish in appearance. Therefore, sun looks reddish at the sunset or sunrise.
Electrophoresis. The colloidal particles and dispersion medium in a given system carry electrical charges equal in magnitude and opposite in sign. It is, therefore, expected that the particles and the medium migrate in opposite directions in an electric field. If experiments are arranged in such a way that only colloidal particles will migrate, but not the medium, the phenomenon is referred to as an electrophoresis. Hence, the migration of electrically charged colloidal particles in one direction under the influence of an electric field is called electrophoresis. The phenomenon of electrophoresis can be demonstrated by an apparatus, as shown here. The apparatus consists of an U-tube filled with colloidal dispersion. Water is added slowly over the soil to form sharp boundaries between soil and water in the two arms of the tube. Two platinum electrodes are inserted in water into arms of the U-tube and are connected to a high-voltage battery. When an electric field is applied, the boundary in one arm is seen to move down, and in the other arm, to move up. If it is observed that the boundary falls gradually on the negative electrode side, and moves up on the positive electrode side, then the particles migrate towards positive electrode, and they are negatively charged. If the reverse occurs, then the particles carry positive charge. If the electrophoresis is allowed to proceed until the particles reach the oppositely charged electrode, the particles are discharged and precipitate out, that is, They coagulate.
Brownian movement. The continuous zigzag motion of fine particles suspended in a gas or a liquid is called Brownian movement. It was discovered in the year 1827 by the botanist Robert Brown and is named after him. For example, let us observe a beam of sunlight entering a dark room. You will find that the dust particles are constantly moving in a haphazard manner. What makes dust particles move continuously in air? You already know that air is a mixture of gases, and gas molecules are always in a state of free random movement. These molecules hit the dust particles from all directions and make them move in an irregular manner. Similarly, if pollen grains are placed in water, they do not remain at rest, but move about continuously and randomly. This is also an example of Brownian movement.